Hey guys, hope everybody's doing well. I just wanted to kind of do like a screen recording of the practice test. I know that you guys are taking the PSATs on Wednesday, and I just wanted to make sure I'm not going to see most of you, so that you had an opportunity to kind of see if you had any questions about problems that we were going over in class. You can watch this. You can skip ahead or really kind of watch as much as you want. What little what you need to go over. And as always, you guys are more than welcome to come see me. Whether it be last band study hall or in the morning or anything like that. I think you guys you'll be fine. Um, so let me know. If the video quality isn't that great, I'll try and make it better. For next time or something like that. Um, okay, so for the first one, I have it's a graph of a piecewise function, and it's asking you to use it for questions numbers 1 through 4. Okay, so the first one says f of x has a local minimum of what, right? Now the big key here is of, right? That's asking you really what is your y value as your local minimum, okay? So you want to be looking as you move from left to right on the graph where you have a local min, what's the particular y value, right? I'm not asking you for the x value here, I'm looking for the y value. All right, so as I look on the graph, I see that I have a local min right here at about -2.5, and the y value is -1. Okay, so that is perfectly fine as the answer, right? So as you move from left to right again, some more, you'll also see, you also have the local min over here as well, and you should notice that the y value is the same. Okay, so for the first one, you just have a local min. The value is -1. The second one, f of x has a local maximum at where? Okay, so again, this is the big key. Where exactly do you have a local max? Okay, so again, you want to look for where is it to the left and to the right, where is it increasing to decreasing. Okay, so the first one that I see is right here. All right, that looks like to be about -1.5. Okay, so that's my first one. So as I move to the right, again, I see that this point here, right, it's increasing to the left of the point, but it's decreasing to the right of it. Okay, so this point right here, that area, that would be considered a local max, right? It changes from increasing to decreasing. Okay, so the x value there would be +1. So that's another local max. Okay. Now the other one that I see would be here at x equals 4. Okay. All right, so local maxes again go from increasing to decreasing. The next one is x-intercepts. Right, so these are pretty straightforward. Where exactly does it cross the x-axis? So I have here at -3, -2. I'm not going to do -1 because technically the y value is not defined there. Okay, so I'm going to keep going to the right. The next one that I see here is at 0, and right there, which is about 1.75. Next one there is about 2.5. Next one there is about 3.5. And the last one is about 4.5. All right, so you have 1, 2, 3, 4, 5, 6, 7 x-intercepts, right? Crosses the x-axis 7 times. All right, now the last one is asking for the range of the graph, right? So these are, again, the y values, right? So I see that, again, my lowest y value was -1, right? And as you work your way up, right? You kind of, if I'm using that piece of the graph, I'm going to stop at positive 1, but I can use this piece of the graph to keep going, right? And this picks up and stops at 2. Okay, so the lowest y value that you have is negative 1. The highest y value that you have is 2. And every value in between negative 1 and positive 2 is included. So that would be your range. Okay, so that's, most of those questions are from section 2.2. So if you guys want to look those over, that would be a good idea. Okay, for number 5, it says if h of x equals 2x squared plus 5, find the average rate of change from negative 1 to 3. Okay, so we talked about average rate of change as being really the kind of the slope of a curve in between 2 points. Okay, it's the slope of the secant line. All right, so your formula here, right, would be the change in the y values over the change in the x values. All right, and if that's my interval, I'm going to let a be negative 1 and b be positive 3. Okay, so I have h of 3 minus h of negative 1 divided by 3 minus negative 1. Alright, so this step that I have here, you guys really, you need to show that. Okay, I know it might not seem like that important, but as you guys work through this, this course, and when you guys take calculus next year, it's very important that you show that difference quotient setup. Okay. Okay, so really what you're doing from there is you're just plugging in, right? So h of 3 would be 9 times 2 is 18. 18 plus 5 is 23. Minus, if you plug in negative 1, that's 2 plus 5, which is 7. Divided by 4. 23 minus 7 is 16. Divided by 4 is 4. Okay, so if you were to connect again, if you were to draw that curve out, right, and connect the points from x equals negative 1 to x equals 3, right, and you were to draw a line between those 2 points, the slope of that line would be positive 4, right? That's the slope of your secant line. Okay. All right, so the next one is graphing a piecewise function. All right, so I would again draw out an axis for yourself. Alright, so I see the first function that I have is 3x plus 4, x is less than negative 1. So when I plug in negative 1 into that function, right, 3 times negative 1 is negative 3, plus 4 is positive 1. Okay, so I'm going to have an open circle there, negative 1, positive 1. Alright, now from there, it has to look like 3x plus 4. Okay, so that's a positive slope. So as I go from left to right, the line should be going upwards. Okay, so instead of going up 3 over 1 to the right, I'm going to go down 3 over 1 to the left. Right, so as you guys look at that line, right, it rises as you go from left to right. Alright, the next one is f of x equals 2 at x equals negative 1. Okay, so at negative 1, positive 2, you want a filled in circle. Okay, that's it, right? It's just one single point on the graph where it's being defined. Okay, so that's all you have to do for that one. And then the last one is 2x squared minus 1, x is greater than negative 1. So if you plug in negative 1 into that function, you get 2 minus 1, which is 1. Okay, so again, you're going to have an open circle there at negative 1, positive 1. Right, now to the right of that point, it has to look like 2x squared minus 1, right, which is a quadratic vertical shift down 1. So if you plug in 0, you get negative 1. If you plug in 1, you get positive 1. Right, so it's going to look like a quadratic, something like that. Right, so again, you guys got to know your parent functions, and it should help you really graph these piecewise functions. Okay. Okay, number 7, f of x is given by that function, g of x is given by that function, and it says h of x is g divided by f. So you have to find the domain of what h of x is. Right? So it'd probably be useful to actually figure out what is h of x. So if h of x is g divided by f, you have x squared plus 3x minus 28. And then f would be 2x squared minus 2x minus 24. Okay, so that's the function that I'm going to be working with, right? So this is a rational function, so I have to be worried about, I don't want a 0 in my denominator, right? So since it's a polynomial there, I have to try and factor it. So what I'm going to do is actually I'm going to factor the top and the bottom, just for this case. Okay, so you have x plus 7 times x minus 4 on the top. On the bottom, if you take out a 2, you're left with x squared minus x minus 12. And if you continue on, you have 2 times x plus 3, x minus 4. Okay? So as you look at that factored form of the function, right, you're really concerned about what the denominator is, right? You can't have a 0 in the denominator. So if we take my denominator and say that it can't be 0, I know that x can't be negative 3 and x can't be positive 4. Okay, so those are two big keys that you have to find out from your domain. Okay, so from there you guys just have to write it. You can write it either in set notation or interval notation. So the domain of h would be all real numbers except for x can't be negative 3 or 4. Or you can do it in interval notation. All right, now if this was a multiple choice question, I would probably give it an interval notation. Again, that's just more common in pre-calc and calculus. But if this was a free response question, you can give me the answer either way. That's perfectly acceptable. Okay. So it says determine algebraically if h of x is even, odd, or neither. All right. So I'm going to use notability, and its fancy features, and paste it down here. Alright, so I know h of x is equal to that. Alright, so when we were talking about even and odd functions, when you have a rational function, right, you have to see what the top is going to be and what the bottom is going to be, right? So if I'm looking at the top, okay, if I'm plugging in the opposite value, right, x squared is not going to change. Plus 3x is going to change to negative 3x, and negative 28 is not going to change. Right? And the bottom, 2x squared is not going to change. Negative 2x is going to become positive 2x, and negative 24 is not going to change. All right, so it should be pretty obvious now that obviously you're not even, right? You didn't get the exact same equation back, right? But it's not odd either. It's not the opposite of what you what you started with. Okay, so the top function here is neither. and the bottom function is also neither. So anytime you have a rational function and one of them is neither, the entire function is not symmetric. So it would be neither for that one. Okay. Okay, now the last one says set up and simplify f of x plus a minus f of x divided by a for some constant a. Okay. So again, this is using your difference quotient. F of x equals 2x squared minus 2x minus 24. Okay. So if I'm going to follow the formula now, anywhere that I see an x term, I'm going to replace that with x plus a. Okay. So the first part, right, you have 2. Instead of x squared, it's x plus a squared minus 2 parentheses x plus a minus 24. Alright, so that's the first part. Again, I replaced any x term that I saw, and I replaced it with x plus a. Okay. Now the second part asks me to then subtract f of x. Okay, so you're going to subtract your original equation. So 2x squared minus 2x minus 24. Alright, so if you guys have that written down, you've pretty much done most of the difficult work. Right? From there, all you have to do is simplify. Right? And the entire thing is divided by a. Okay? Right? So all you do from there is you just simplify. Okay? So x plus a squared is going to turn into x squared plus 2xa plus a squared. Right? And then if you double that, you're going to be left with 2x squared plus 4xa plus 2a squared. Okay? Minus 2x minus 2a minus 24. Alright, so that's the first part that I have in dark blue. That's now simplified completely. And then I'm going to distribute my negative. So negative 2x squared, positive 2x, and positive 24. And again, that whole thing is going to be divided by a, which is your constant. Okay, so once you get to there, you want to look to get rid of some things. Right, so 2x squared is going to cancel out negative 2x squared. Negative 2x is going to cancel out positive 2x, and negative 24 is going to cancel out positive 24. Okay, so that's going to happen every time that you do this. Things are going to cancel out. Okay, so once you get to here, you have 4xa plus 2a squared minus 2a divided by a. Okay, now I remember from the quiz, a lot of you guys kind of stop there. You want to keep going, right? You want to try and get rid of this a term that you have out of the denominator. You want to get rid of them. Alright, so once you get to here, you want to factor out the a term in the top. So you have now 4x plus 2a minus 2, and that's going to be divided by a. And obviously, the a terms here are going to cancel each other out. Alright, so your final answer is 4x plus 2a minus 2. Alright, so make sure, again, you guys you can multiply everything out, and just, again, follow the formula. Right? It's given to you. Right? So all you have to do is just simplify it out. Okay, so number 8 asks us to write it in standard form, find the domain and range, and then we want to sketch the graph. Okay, so I'm probably going to sketch the graph and then figure out what the domain and range is. That's probably a little bit easier. Alright, so if I put this one in standard form, I have negative 3 parentheses x minus 2 squared plus 1. Okay, so I have an x-axis reflection, vertical stretch by 3. I'm moving to the right 2 units, and I'm moving up 1. Okay, so again, refer to that blue sheet that we used in class to help you figure out what those transformations are. Okay, so this is a quadratic, I know, because that's its parent function, right? And a quadratic always has a vertex at 0, 0, all right? But if I'm going to shift it to the right 2, and then up 1 unit, right? Now my vertex is at positive 2, positive 1, okay? Now instead of opening up, like a normal quadratic would, it's going to open down because of the x-axis reflection. Okay, so that's a rough sketch of what that function looks like. Okay, so again, I'm not going to ask you exactly, to draw this one out, but I might ask you a property of what this function has. Right? I might ask you, okay, what's the range of this function? Right? So you should graph it, and then you should be able to figure out what exactly its properties are. Alright, so the domain here would be all real numbers because it's a quadratic, and then the range would be, I see that the highest value is positive 1, so it goes from negative infinity to positive 1, close bracket. Okay? So again, put it in standard form and then sketch them the best that you can. Alright, so the second one is actually mostly in standard form for us, except for the inside part. Alright, I always want the x term to be by itself, so what I'm going to do is I'm going to take out the 8, and then what I'm left with would be x plus 1/2. Alright, now by doing that, I know that I'm shifting to the left 1/2. Right? If I didn't take the 8 out, I'd be confused with what exactly to do. Alright, so I have a vertical shrink by 1/2. I have a horizontal shrink by 1/8, shifting it to the left 1/2, and I'm shifting it down 3. Alright, so again, your parent function is the square root of x. Okay. So if I shift it to the left 1/2 and down 3, my first point is going to be at negative 1/2, positive 3. Right? And again, it's going to look like a square root. So it's going to be a little bit flatter because of the compressions, but it'll look something like that. Okay? So your domain here, right? It's a square root function, right? All the x values are defined to the right of negative 1/2. Okay, so it would be negative 1/2 to infinity, and then your range, that's h. Right, all my y values, the lowest y value that I have is 3, and then they're all going up from there. So it would be, that's actually negative 3, sorry about that. That's negative 3 to positive infinity. Alright, so that's a rough sketch of what that graph looks like. Alright, so for letter C, this is a rational function now. So if I put it in order, I have now negative 3 parentheses 1 divided by 2 parentheses x minus 5 over 2 plus 2. Right? So by taking out the 3, again, I know exactly what's going on with my function. Right? So now I have a x-axis reflection, vertical stretch by 3. I'm shifting it to the right 5/2, right? And I'm also horizontally compressing it by 1/2, and I'm shifting it up 2. Alright, so this one has a lot going on. Alright, so your parent here would be 1 over x. So you have a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. Alright, that's the usual 1 over x graph. Right? Now, because we're moving it to the right 5/2 and we're moving it up 2, that's going to change where my asymptotes are. So if I'm shifting it to the right 5/2, that's where my vertical asymptote is going to be now. Okay, so that's going to be right about here. So that's x equals 5/2. Alright, now my horizontal asymptote is usually at y equals 0. Because I'm moving it up 2, that now horizontal asymptote will be at y equals 2. Okay, so now I just have to fill in exactly where the rest of the graph goes. Okay, so normally 1 over x kind of looks like that. Alright, but because of the reflection over the x-axis, both of those parts of the graph are going to be flipped to the other areas. Okay, so this is now what your graph should look like. Again, these sketches don't have to be perfect. You just have to kind of get the main idea from them. Alright, so my domain would be negative infinity to 5/2 union with 5/2 to infinity, and then the range, that would be negative infinity to 2 union with 2 to infinity. Alright, so again, refer to your 1 over x graph and exactly how, those different properties to help you figure out how that one looks. Okay, now the last one, again, I can put some things together here when I'm writing it in standard form. Okay, so I have -2 parentheses -2 x plus 1. That should be parentheses, sorry about that. X plus 1. Now if I put my two -2's together, that's going to give me a -4. Okay, so you have a reflection over the x-axis, vertical stretch by 2, reflection over the y-axis. However, since this is an even function, you're not going to see a y-axis reflection. Okay, so this one does, the y-axis reflection does not show up. Horizontal shrink by 2, move it to the left 1, and then down 4. Okay, so I'm going to draw my graph. Right, so an absolute value usually starts at 0, 0, right? But I'm going to move it now to the left 1 and down 4. So my vertex, in this case, is going to go to the left 1 and then down +4. Okay, so now, again, because of your x-axis reflection, it's going to open downwards, kind of like that. Alright, so your domain would be all real numbers because it's an absolute value, and then your range would go from negative infinity to -4. Close back. Sorry about that. Alright, so that's, if you guys can do those, you should be good with the questions that I'm going to ask you. Alright, so the last two we have here, again, nothing really too difficult, just a little bit more thinking. So it says f of x is -7 over 3x plus 3, and g of x is x plus 1. Find the domain of h of x if h is a composition of those two. Okay, So wherever I see an x term in the f function, I'm going to replace it with g of x. Okay? So g of x is the square root of x plus 1. So I'm going to replace the x term in the f function with, I want to do that, with this entire thing. Okay? So h of x now is going to be negative 7 divided by 3 square root of x plus 1 plus 3. Okay, so now I want to find the domain of this, right? So you have a rational function, so you have to be worried about what the denominator is, and it also has a square root. So you have to be worried about what's inside the square root. Okay, so I have x plus 1 needs to be positive, so that tells me that x has to be greater than or equal to negative 1. Alright, now the other part is you got to make sure that the denominator does not come out to be 0. Alright, so if you subtract the 3 over, you get negative 3. You divide it by 3, you get negative 1. Alright, now if you're not totally sure, right, you can kind of stop at this point, right? Because the square root is never going to give you a negative number, right? It's just not possible. Alright, but however, if you didn't recognize that, you can keep going, right? So to get rid of the radical, I'm going to square it, right? So that gives me x plus 1 can't be positive 1. Subtract the 1 over, I get x can't be 0. Okay. Now, what you have to do there is you have to check that answer up in your original function. Okay, so if you plug that in, what you're hoping for is that you get the denominator come out to be 0. Then you can move on. Alright, but if you plug 0 in, you get 0 plus 1 is 1. The square root of 1 is 1. 3 times 1 is 3, plus 3 is 6. Okay, so that does not, the denominator, when you plug in 0, right, you do not get a 0 in the denominator. Okay, so what that is, this is not going to be, that's part of your domain. Okay, so this is what's called an extraneous solution. Alright, so when you write for me the domain, you're not going to include 0. Okay, because 0 is part of the domain. Alright, so you can write your domain of h is the set of all real numbers. X has to be greater than or equal to negative 1, or negative 1 to infinity. Alright, either one of those is acceptable. Alright, so the big thing here is you just have to check your answer. Okay? Alright, the last one. You have f of x equals 2 times square root of 2 minus x minus 1. Where is it decreasing? Alright, so again, I would graph this to figure out exactly what it looks like. Okay? So if I put it in order, you get 2 square root of negative x plus 2 minus 1, which turns into 2 square root of negative 1 times x minus 2 minus 1. Okay, so this is a y-axis you have a y-axis reflection, vertical stretch by 2, shift to the right 2, and down 1. Okay, so you have a regular graph. Right, so the square root usually goes in that direction, right? So what you're going to do, right, you're going to move to the right 2 and then down 1. Okay, so based off of that, right, that's going to be your starting point. However, because of the y-axis reflection, instead of moving it to the right, it's going to move to the left. So it's going to look something like, not like that. It's going to look something like that. Right, so that's what that graph looks like. So you want to look, okay, where is it decreasing, right? Where is it going down from left to right? Right? So as you come in from negative infinity, it's decreasing all the way until you get to that value right there, which is x equals 2. Okay? So f of x is decreasing from negative infinity to positive 2. All right? You can, again, when you're doing increasing and decreasing, you can always leave them as open intervals. Okay? Yeah, so that's the test review. Again, if you guys have any questions, feel free to stop by, ask me some questions in person. If not, I'll see you either Thursday or Friday, and good luck on the test.